So let's begin this video by talking about what we're looking at exactly. So we're moving on to chapter 13. This is the last chapter we're going to be looking at for the year. All right, so celebration. And we're going to start off by looking at 13.1, which is on page 788. And we're focusing on, in this lesson, on the law of sines. Okay, so previously in the very last lesson we did before arctangents and their inverses, essentially, we looked at right triangles and solving right triangles. And now we're going to look at solving oblique triangles, which means that there are no 90 degrees. Okay, so oblique triangles are not drawn as right triangles. Oblique triangles can look like that or like that, right? Those are our oblique triangles. And there are 4 cases to look at when solving oblique triangles. The first one is if you're given 2 angles and any side. So if you remember from geometry, that's angle, angle, side, or angle, side, angle. For the second case is given 2 sides and an angle opposite one of them. So that's side, side angle. Okay. And then we've got case 3, which is given 3 sides, that's side, side, side. And case 4, given 2 sides and their included angle, that's side, angle, side. So the ones we're going to be looking at first are the first 2 cases. So that's when you're given 2 angles in any side and 2 sides and an angle opposite one of them. Okay, and the reason why we're looking at those first is because we will use law of sines, which is the focus of this lesson, to solve the first 2 cases. And so we have to define what law of sines is. Law of sines is if ABC is a triangle with sides A, B, and C, then A over sine A is equal to B over sine of B is equal to C over sine of C, where A, B, and C here, where my pointer is, are angles. Or it can also be written as sine of angle A over A equals sine of angle B over B equals sine of angle C over C. Okay, so we're going to be using those formulas and we can rearrange them any way we want. So if we want to set A over sine A equal to C over sine C, that is completely fine. So let's go ahead and look at some examples. The first thing we're going to look at is case 1. So this is when we have angle, angle, side, all right, in the very first example. So they gave us that angle C is 102.3 degrees, angle B is 28.7 degrees, and B is equal to 27.4 feet. So I'm going to draw this triangle to the best of my ability. Looks something like that. Okay, C is a very large angle, so I'm going to put that there. Opposite angle C is side C, A, B, B. Okay, we know that angle C is 102.3. We know that angle B is 28.7. And in order to find angle A, we're going to do 180 minus the sum of 102 and 28.7. And this adds up to 49.0 degrees. Okay? And then what we need to find is side A and side B. So first we're going to solve for side A. So we have side A over sine of A is equal to side B over sine of B. So A will be equal to sine of A times B over sine of B. I'm going to plug in what I know, which are angles A and B and side B. So I've got sine of 49.0 times 27.4 over sine of 28.7 degrees. So A is going to be equal to 43.06 feet. Don't forget those units. Now the next thing we're going to do is solve for C. And it might be habit to just reach for Pythagorean's theorem and do that to solve for the last side. You cannot do Pythagorean's theorem with oblique triangles though, okay? Pythagorean's theorem works solely with right triangles. So what we have to do instead is the exact same steps we just did, but this time replacing A with C. So side C over sine of C is equal to side B over sine of B. So side C is equal to sine of C times B over sine of B. and then plug in. So we've got sine of 102.3 times 27.4 over sine of 28.7. Plug it into your calculator and you get 55.75 feet. And those are our answers because we've now solved our triangle for all of our missing pieces by finding angle A, side C, and side A. So now let's move on to the second example that we've got of case 1, which is when we're given two angles and a side where the side is opposite one of them, I think. Yes. Okay. Sorry, the angle. No, it's angle, side, angle. So the side is trapped between the two angles. My bad. So the example we have here is A is equal to 43 degrees, B is equal to 98 degrees, and side C is equal to 22. So again, first thing I'm going to solve for, well, first I'm going to draw my triangle. The way you draw your triangle is not that important as long as you label it correctly. Angle B is 98 degrees, so that's half of 180, so that's going to tell me it's the largest one. And then side A, angle C, side B, side A, side C. We know that A is 43. Okay, so I'm going to add up A and B and subtract it from 180 to get angle C. So this will be 39 degrees. And then I'm going to solve for A, for side A that is. So I've already kind of done the algebra for it. So if you remember from the first example, side A is equal to sine of A times C over sine of C. This time we're going to use sine of C just because they gave us side C. Okay, so this will be equal to 22 times sine of 43 over sine of 39. Plug it into your calculator and you get 23.84 feet. And then we just need to find side B. So again, we're going to use the same formula pretty much, just changing out the A with a B. So sine of B times side C over sine of C. So this will be sine of 98 times 22 over sine of 39. And when you plug it into your calculator, you get an answer I didn't put down. And you get that side B, when I plugged into my calculator, is 13.98 feet. Okay. Now let's move on to case 2. Case 2 is called the ambiguous case, all right? That is, they give us two sides and an angle. What's ambiguous about this is that this case can have no solution, one solution, or two solutions, all right? And you're probably thinking, well, how am I supposed to know which solution is going to happen? When? You're going to ask two questions at the beginning once you get your pieces of your triangle they give you at the beginning. First question, is the angle given acute? All right. If the answer is no, then you have one solution. Exactly. Okay. Second question, is the side opposite the angle the smaller of the two? If the answer is no, then you only have one solution. If the answer is yes, then you could have no solutions or two solutions. But it has to be yes to both 1 and 2 on your questions in order to have two solutions. Okay? So, let's look at the no solution case. We're given A equals 15, B equals 25, and angle A is 85 degrees. So question 1, is our angle, which is A, acute? The answer would be yes. Question 2, so the opposite side would be side A, less than side B. The answer is also yes. Both yeses. I don't know how to spell yeses. So, could have no solution or two solutions. Okay, so we've narrowed it down. We know we can't have one solution. But you're probably saying, well, how am I supposed to know if I have no solution or two solutions? What you're going to do next is solve for angle B. So sine of B over side B is equal to sine of A over side A. Sine of B is equal to 25 times sine of 85 all over 15. This is equivalent to 1.660. Here's the issue. This is greater than 1. So if you tried to take the inverse of 1.660 in your calculator, you should get domain error. Okay, this is because since it's greater than 1, we cannot get an angle. There is no angle corresponding to 1.660. So therefore, there is no solution. Okay. Now let's look at one solution. In the one solution case that I have here on the screen, it says side A is equal to 22, side B is equal to 12, and A is 42 degrees. So question 1, is angle A acute? The answer is yes, right? Because 42 is less than 90. 2, is side A less than B? No. So we only have one solution. Okay? So then first thing we're going to do is solve for angle B. So sine of B is going to be equal to 12 times sine of 42 over 22, which is, we're going to then do B is equal to sine inverse of 0.3649, which is about 21.41 degrees. To find angle C, we're just going to add up angles A and B and subtract them from 180. So this is going to be 180 minus 42 plus 21.41, which will be 116.59 degrees. And then to find side C, we're going to do sine of C over C is equal to sine of A over A. So then we want to solve for side C. So we're going to cross multiply, and then we get A times sine of C is equal to C times sine of A. We want to solve for the side, so C is equal to A times sine of C over sine of A. I suggest doing all this algebra first before you start plugging in numbers, because it's a little bit easier that way than hopefully remembering to carry every single digit. And so then side C is equal to 29.40 when I plug in the appropriate values. Okay, so that's the easy one. Next, we're going to go to the two solution case. This one is not an easy problem. Okay, two solution case. We are given side A is equal to 12, side B is equal to 31, and angle A is 20.5. So first thing we're going to do, question 1, is A acute? Answer is yes. Okay. 2, is the corresponding side, that is A, less than B? Answer is yes. Therefore, we can have no solution or two solutions. Okay, so we've eliminated the possibility of one solution. Next thing we're going to do is solve for angle B, because we want to make sure we don't have no solution. So sine of B will be equal to 31 times sine of 20.5 over 12. All I did was plug in my values from above. This is equal to 0.9047, which is less than 1. So therefore, I have two solutions. Okay? So then I take the inverse of that, and I get angle B, or in this case, I'm going to name it B1, is equal to 64.8 degrees. To find my second solution, I'm going to subtract our original B1 right here from 180. This will be 115.2 degrees. And then I'm going to find each triangle. So what I have left to find for my first triangle, so B1, I need to find angle C and side C. So to find side C, I need angle C. So C1 will be 180 minus the sum of B1 plus A. So this will be 94.7 degrees. And side C will be equal to sine of C times A over sine of A. When we plug in our appropriate values, we get 34.15 for C1. Okay? For the second triangle, to find our remaining angle, which is C, we're going to, again, subtract the sum of B2 and A from 180, so we get 44.3 degrees. And then to find side C2, we're going to do sine of C2 times A over sine of A. So this will be equal to 23.93 once you've plugged in all the appropriate values. And that's our answer, or answers. Oops, sorry. Okay, so the last part of law of sines is finding the area of an oblique triangle. So we have formulas for finding the area of an equilateral triangle, finding the area of a right triangle, and now we're going to add on the formula for oblique triangles. And what's nice is that this formula uses law of sines. So it says that area is equal to 1/2 side B times side C times sine of A, or 1/2 side A times side B times sine of C, or 1/2 side A times sine C times sine of B. So essentially all you're going to do is you're going to see what size was I given, what angle was I given, and which of the three formulas can I plug it into. So in 30, we're given angle A, side B, and side C. The first thing I'm going to do is convert angle A into degrees because I've got 5 degrees and 15 minutes. I know that there are 60 minutes in 1 degree. So angle A will be 5 degrees and 15 over 60, which will then be 5.25 degrees. Okay, I notice I'm given angle A, side B, side C, so I'm looking at this first one here because it's looking at angle A, side B, side C. So area will be 1/2 times 4.5 times 8.5 times sine of 5.25 degrees. Plug that all into my calculator and I get 17.50. And that's it. Okay, so this is the end of lesson 13.1. If you would like to stop here, maybe try a couple problems from law of sines, that's probably a good idea, just to pick some random ones and try them from the homework. If not, that's okay. You can continue on to second video on law of cosines.